Hello, my name is Rachel Hayden and I'm a fourth year civil engineering student at the University of Bath. I'm going to talk to you about my experience and my journey through the construction industry so far, and also my idea for you for a CREST project. So, who am I? Well, I grew up on a small island called Jersey in the Channel Islands and went to an all-girls secondary school called Jersey College for Girls. I first got into engineering by competing and ultimately winning a competition to build a bridge out of pasta. I then gained more experience in engineering and went on to study A-levels in maths, physics, music and further maths. I then went on to study a civil engineering degree at the University of Bath and am now in my fourth year, having already completed a year in industry with Laing O'Rourke. Along the way, I've been fortunate enough to win several awards, which have once again helped me in my journey to where I am now. These have included the Forward Women in STEM Scholarship in 2017, the Royal Academy of Engineering Leaders Scholarship in 2019, and the UK Construction and Engineering Undergraduate of the Year 2018, which allowed me to have an all expenses paid work experience in Australia in the summer of 2018. So I wanted to start by talking to you a little bit about some of the exciting projects that I've been able to have the experience working on so far in my career. So the first one is Crossrail. Now, Crossrail is the new multi-billion-pound underground railway line they're building in central London. I had the experience while I was still at school before even going to the University of Bath to start my civil engineering degree to gain some work experience at one of the main stations along the route called Farringdon. I've been fortunate enough to be able to visit the site 6 times over 3 years and to be able to see the development of such a large infrastructure project being built has been quite incredible. So this included visiting the 2 stations that they are building, the ticket halls, at Farringdon, as well as seeing the tunnels and track being laid. So I was fortunate enough to receive an ICE CREST scholarship with Laing O'Rourke when I started university. This not only helps to fund my university degree, but also allows me to gain valuable work experience during my university degree. So my first summer placement was on the Hinckley Workers campus at Bridgewater. So as a result of the new Hinckley Point C power station they're building in Somerset, they realised they needed to build more accommodation to house all the workers that will be building this project. So I was involved with a lot of the groundworks and substructure to be able to house all these off-site construction volumetric buildings you can see in the image on the left. So this project was the first project that I worked on with the use of off-site construction. So as you can see here, full volumetric buildings would be lifted in place using a crane. These volumetric buildings were manufactured off-site in a factory and included complete internal fit-out from the bathrooms to the bedrooms, etc. This led to a significant reduction in the production and assembly time, which enabled us to deliver the project in a much shorter time than normally possible. So this is just another image showing these volumetric blocks being assembled. So we had 2 campuses on this job, one directly close to the Hinckley Point C nuclear power station, and this one was in Bridgewater, and I gained experience on both sides. So as a result of winning the Construction and Engineering Undergraduate of the Year award in 2018, I gained an all expenses paid summer placement in Australia in the summer of 2018. This was an amazing experience where I got to see so many projects over 3 weeks in Australia. So I spent the first week in Sydney. Some of these photos are taken on the 100 Mount Street project, which will be the tallest high-rise building in North Sydney when it's completed. I also had the opportunity to work on Sydney Metro, which is the new underground that they are building in Sydney, and also gain behind-the-scenes access at the Sydney Opera House, as this was a project that Laing O'Rourke were currently refurbishing. I was then flown to Yamba in the second week of my experience to work on the W2B Project, which is the Woolgoolga to Ballina route, which is a highways project. So they are upgrading the current Pacific Highway from a single lane to a dual lane carriageway. So this stretched over 155 kilometres, and along the way 150 bridges had to be constructed, of which 3 of these were major projects within themselves, spanning over a kilometre in length. Here are some photos of me along the route. And there was a lot of cut and fill operations to enable the new route to be established. And also, as you can see, a lot of bridges being built along the way. So I spent the 3rd year of my degree working with Llangollen at the SCCC Hospital in Wales. This is otherwise known as the Grange University Hospital and is a specialist critical care centre that's going to be opening in Cwmbran that will be providing care to over 600,000 people living in the area. It's also a 70-60-30 project for Llangollen, which means that over 70% of the components used to build the hospital are built using offsite manufacturing techniques, which has led to a 60% reduction in the on-site personnel required and a 30% reduction in overall programme time. So during the 12 months, I was responsible for many components of DFMA, which is known as Design for Manufacture and Assembly, otherwise known as Offsite Construction. So these included putting in place precast sandwich panels, planks, wall units, parapets, and also for 6 months I was responsible for a £3 million package delivering the off-site manufactured bathroom pods, which can be seen in the image in the middle with some of my team. So within that project, we had to install over 241 fully furnished bathroom pods that came wrapped up, as you can see behind us, and lift them all into place. This involved lots of liaising with both the logistics teams to be able to get us the bathroom pods delivered at the right time, but also with the production teams. So the pods would be manufactured in 3 different factories. So the base of the pods would be cast first in concrete, then these would be transported to another facility called Smart Wall, where the walls would be erected. Then these would be transported to a factory in Oldbury, which would then involve installing all of the mechanical and electrical services. So the showers would be in, the mirrors would be installed, all the furnishings you'd expect in a bathroom, and then this would then be delivered to site where me and my team would install them in the right place. So this is another image showing the Grange University Hospital during construction. Now at its peak, you can see there were 6 tower cranes on site lifting off-site manufactured components into place. Now, one of the great advantages of using off-site construction is that you're able to deliver a project in a much shorter time than would be possible using traditional methods. Now, the Grange University Hospital was meant to be opening in 2021, the summer of 2021, but as a result of the COVID-19 outbreak, the team are currently handing over the ward block, which will contain approximately 300 beds, in 2 weeks' time to treat patients who have contracted COVID-19. So those were some projects that I've had the experience of working on and seeing off-site construction in the workplace. But during my time at the University of Bath, this year I have been doing a research project in off-site construction, looking into the skill set and the background of operatives building off-site manufactured products in the UK construction industry. So this year, I became a semi-finalist in the Telegraph STEM Awards Innovation category, where we were tasked with improving mechanical and electrical modules used in the construction industry. So my idea was Plank Plus, which is an idea that you attach precast concrete planks to off-site manufactured modules in a factory environment before them being delivered and assembled in one piece on a construction site. So this is just an example of showing innovations with off-site manufactured components in real life. So I know I've mentioned in this presentation quite a lot about off-site manufacturing and off-site construction. So I just wanted to talk to you a little bit more about what that actually means. So offsite manufacturing basically enables us to move construction activities that would have traditionally been done in either the rain, snow, or hot climate into a more controlled environment, such as a factory. By doing this, we are able to realise a lot of benefits, such as an improvement in health and safety, increased productivity of the workforce, a reduction in waste, faster construction, and increased quality of the products we are manufacturing. So as you can see from these images, offsite manufacturing can come in many forms, from volumetric bathroom pod units, which can be seen on the top left, to smart wall units, which contain all the services within a wall unit, which can be seen in the middle at the top, to mechanical and electrical modules. So these are units that contain all the services, such as hot and cold water pipes, cables, electric cables, etc., and ducting. To precast concrete units. So on the bottom right, you can see precast columns, some wall panels in the background, and also concrete planks, which would make up the floor. To timber units, can be seen on the bottom middle, and on the left, volumetric buildings. So this is an image, once again, taken at Hinkley Point C. So as a STEM ambassador, I've been asked to come up with and give you some ideas for a CREST project as a result of a lot of you no longer working towards your GCSE or A-level examinations. So I was thinking that perhaps you could come up with an idea utilising offsite construction and how it can be used to tackle the COVID-19 coronavirus outbreak, as it is so topical at the moment, and is the reason why a lot of you aren't able to sit your exams this summer. So just some examples of how offsite construction has already been used. So one example that you've probably seen in the news is in China, where they built a hospital in only 10 days to tackle COVID-19. So obviously this was only possible as a result of using offsite manufacturing techniques. So that was offsite construction on quite a large scale in China. But something a bit local to me, for example, I've now come back from university and now isolating in Jersey, back home with my parents. And in Jersey, we are building a £14.4 million NHS Nightingale Field Hospital in the island to provide 180 beds for COVID-19. This will be built in approximately 3 to 4 weeks, and once again would not be possible without offsite construction techniques. So just something else that perhaps you could use offsite construction for. So at the moment, we've talked a lot about offsite manufacturing and offsite construction being used to build hospitals. But something else that's quite topical is obviously these testing facilities. So perhaps you could think about how we could use offsite construction in producing testing facilities that can be easily moved around countries to test patients in areas that most need it. So I hope you found the presentation informative and has given you some ideas about possible CREST projects you could get involved in. I think offsite construction is such a growing technology being used in the construction industry, and it would be super exciting to see how it can be used to tackle the COVID-19 outbreak. So best of luck with your submissions, and I hope it goes